Okay, so in this tutorial exercise, week 9, we'll try to do some of the exercise on the confidence interval. Remember the CI, confidence interval estimation for, first we'll try to cover the proportion, then we'll move to the CI estimation for the population mean, where the sigma value will be given, and then finally we'll see the confidence interval estimation for the population mean, like for the mean, where the sigma value is population mean, where the sigma value is unknown. So that's what we have covered in the last 2 weeks, right? So let's go through more and more practical exercise. Take your own time in understanding these sums, these exercises, and I won't be in the rush. So I want everybody to work on your own paper, try to solve the sum on your own paper, and try to match. Is there any gap, or is there any differences in between what you are getting and what we are? So idea is we will try to do it together here. So no problem with that. Is there any specific issue with anyone? And today, even after the class, I will stay here to solve some of the issues if you have, in terms of like those who has doubt, need clarification and all. I will be here for longer hours, so don't worry, because in my house still the wireless is not working, so I will stand here. I'm in at an IC, so I will stay here for longer hours to give you additional inputs, additional support. So don't worry for that. And maybe we'll talk about, I have received one mail, certain some of you guys are still like struggling with, I understand it's not a face to face and it's difficult. I'm taking this one as like really big challenge, not so easy to give you the statistics inputs to the online teaching. I can understand it's a huge challenging and huge stress some of you are taking in terms of understanding. You're trying your best, I know that, but yes, for that I will be there. Even today after the class, I will be here for another 1 hour. I mean, 4 to 6, and then 6 to 7 extend. I will extend another 1 hour today. So those who wish to have clarification can clarify. Even on Monday, coming Monday, like after 10 to 12 classes, I will be here for 2 more hours. I will give you 2 more hours for those who wish to have any clarification, any doubt in any of the topic. Say with me. No worries. I'm there to support you. I know you guys are trying to improve, and your progress, I can track your progress. Like even some of you, we are not very good in during the initial weeks, but later on the performance has been exponentially increased. So I'm happy, but I know at the same time, not all the 5 fingers are the same. So I know the challenges someone can face individually at the different levels. So keeping all those minds, I'm available here. I will discuss about all this. So let's go through the exercise together. Let's attempt the first exercise 1. A survey poll of 1,000 randomly selected adults shows that 460 of the adults say that the public speaking is an activity that they dread the most. So calculate the 95% confidence interval for the unknown population proportion of the adults who says that the public speaking is the activity that they dread the most, they challenges the most. So let me turn you towards the whiteboard. Only one thing, don't try to miss the face-to-face session. Although I know some of you are dependent on you think that the video is available to you, but the kind of face to face, if you're sitting, even understanding and listening, that could give you a kind of better competitive, like better is more advantage in compared to the what those who are just listening the recording one later on. Don't try to miss any of the class session, and all the timetables are updated every time on the Moodle and on your Navitas website. So whatever, if you're seeing there, just try to be attentive in terms of not missing any of the class. So be careful on that. So what is given in this sum? Try to analyze to make it more clarity. Okay. So we have covered in the week 8 and 9, right? We have covered what we have covered. We covered about the confidence interval altogether. As confidence interval of proportion, we have covered in the week 8, one of the session, and then in week 9, I mean in terms of the Monday, we continued with the confidence interval of mean with the sigma known and sigma unknown. And the later half we started with the hypothesis testing. So don't worry, if the enough time will be there, then I will go to the hypothesis testing in today's session. Otherwise, we'll continue with on the Monday. But whenever I will start with I will start the hypothesis testing, I will give you the quick review. I will repeat some of the key concepts once again. So those who are struggling, stay with me. No problem. It won't be a big problem. So exercise number 1. So it clearly says that it's a case of proportion, right? It is given because they calculate 95% of the CI for the unknown population proportion. So this is the case of population proportion. And then you need to keep in mind the formula you have to apply in order to calculate the Z score or the T score, depending on the situation, depending on the kind of information you have given. So this is the case of population proportion, where the size n is what is given. So try to make a note on what is given to you. First, try to make a note on that.
And
so what is given here? N, value of n is given. So n is given a sample of 1000, randomly selected. Okay. So that 460 of the adults are saying yes, something like that, yes or no. So 460 out of 1000. So what we have to find out? Proportion, population proportion, P hat. You need to be careful. Although this exam, in the final exam, we are not going to see the complete write-up. I'm just interested in seeing the final answer. But just be careful. What is P and what is P hat? So throughout throughout the classes, I stick to the certain notation, certain notation for denoting this construct. So P hat I'm always using for the population proportion, whereas P I'm using for the population proportion, whereas P hat I'm using for the sample proportion. Right. So this sample is randomly selected, criteria is fulfilled, and value is given. So P hat is population proportion, the sample proportion. That is the how to calculate the sample proportion. Over here it is 460. That is the item for our interest divided by the sample size. That is 1000. So the P hat value is given 0.46. And then you have to find what you have to do, the calculate the 95% confidence interval. 95% confidence interval. So if go back and recall what 5 stages we have. Let me take you to that slide for a quick revision. It was the slide 8, I think. Week 8. Yeah. So we started in the week 8, the confidence interval is estimation for the proportion. So if you remember the critical value, it's important for us. Like this sum is asking for 95% confidence interval. So in that case, the critical value Z alpha by 2. Let me note it here. Z alpha by 2 will be 1.96. For 99%, 2.575, and for 90% it is 1.645. And then we have seen that which formula to use for the finding the margin of errors. So let's go through these 5 steps. The sum is to calculate CI, confidence interval, but you need to follow these 5 steps one by one. So first one is requirement. Does this sum or this exercise fulfill the requirement of the normal distribution, right? So for that, what condition we have for the requirement? NP hat and N1 minus P hat. So stage number one, find out NP hat value and N1 minus P hat. Is that greater than or equal to 5? If yes, then proceed, otherwise should not. And it is clearly mentioned that the sample is a random sample selection proportion. So what is NP? N into P. It's clearly you can see N into P is the same as the 460, right? 1000 into 0.46. So 460 greater than 5. Even N1 minus P will be 540. So that greater than 5. So this requirement is fulfilled. The second stage is find the Z score. So this requirement is fulfilled. I'm putting the tick over here. What is the second stage? Find out the Z alpha by 2. Find the Z alpha by 2. So what is the critical value? So that is critical value that is Z alpha by 2. So in the case of 95% confidence interval, this is important here. If you could recall, if 95%, that means the alpha value, how much is the alpha value? 0.05. This is important. 90%, then it will be 10%. Alpha value is 0.10. And if it is 99%, then it is 1%. So 0.01. So this is alpha 0.05. So alpha by 2 will be 0.025. So if you calculate using the Z score table, otherwise just one of the table I have displayed you. So you can use from there itself. So Z alpha by 2 at 95%.
0.025.
How much it is?
0.025.
No, that is the alpha by 2 value. But what is the Z alpha by 2?
1.96.
Exactly. So the critical value will be at alpha by 2, 0.025. The critical values, Z alpha by 2 value will be 1.96. So that you don't have to go back and just use the table. Just now I saw you the table for the 95%, 99 and 90. So the critical value you have calculated 1.96. What is step number 3? Calculate the margin of error. That is E. For calculating the margin of error, you have to apply the formula Z alpha by 2 into P hat 1 minus P hat divided by N square root. All the values as given. Z alpha by 2, you have calculated 1.96, and P hat value the sample proportion. We know that sample proportion is how much? It is 0.46. So this part alone 0.46 into 0.54 divided by n. N is 1000 square root. Try to solve this one. Try to solve that E part, margin of error.
0.016.
Others, you also continue, try to do this one.
What you get?
Yes.
16.
0.03.
Value of how much is coming? This one 0.46. This p hat 1 minus p divided by n square root. What value is coming from this?
0.016.
0.06.
Oh,
4. Okay. And together,
yeah.
all together,
Wait, I don't think that's right.
No, it's 0.05.
Yes, 0.16.
Yeah, that one.
Yeah,
Zero-
that's right.
The answer altogether is 0.016, I think.
okay, all together I know I have the answer. All together it should come 0.031 somewhere. Is that matching?
Yeah, it,
0.0.
Yeah, that's right.
Okay, so all together, so you just do this calculation, minor calculation, use your calculator carefully and then just find out. You will get the margin of error as a 0.035. The fourth step is you need to find out P hat minus E, P hat plus E. So what is P hat minus E and P hat plus E? So P hat we have 0.46. So that is 0.46 minus 0.031, comma 0.46 plus 0.031. So what is the confidence interval? You will get the confidence interval as 0.429 and 0.491. Try to match your answer with this one. Try to match.
Yeah, that's right. That's good.
You must get this interval. That is our interest, right? That's what they're asking in the question. What is the confidence? Let me see, the screen is captured.
we
Yes. Any doubt? Somebody was asking something? No. Yeah, I think so. Whole screen is being captured. So okay. So what is the stage number 5? Stage number 5 is you need to make a conclusion. Stage 5 is conclusion. So we are, first time I'm writing again, we are 95%. So that is given. So we calculate everything for the 95. We are 95% confident that, try to write it in your own sentence, that the interval from 0.429 to 0.491 interval 0. That's what we got it, right? So 0.429 to 491 does contain the population proportion does contain population proportion what is population proportion? P, full stop. That is a bit short. Either you can extend it by saying that does contain the population proportion of adults, to say that public speaking is activity they dread the most. So that's up to you. Otherwise, you just close it here. Because with this sample proportion, we are trying to make an inference regarding the population proportions. That's why we have, at the last sentence it says that does contain a true value of population proportion P. Is this clear? This sum is clear or any doubt? Is this sum is clear to everyone?
Yes.
Yes.
Okay, instead of saying yes, those who are struggling, still not able to understand the states, they can talk. They can talk, they can interrupt anytime. And if you're not asking here, I'm assuming that you don't have any issues. So that is the like kind of wrong impression I'm getting. Like, I know some of you are struggling all the time. So please ask, especially at my request, humble request to those who are, some of you I know is 10%, 20%, 30% struggling. So just be interactive, right? Not allow me to move to the next question until everything is clear over here. That is my humble request to you. Please ask. And if you are not interacting, I'm assuming after a certain time that everything is okay, then I will move to the next question. These steps are very formal steps, right? You just follow, use it, get the answer, just give the kind of your result, interpret the result. This one is quite challenging, right? This one is quite challenging. So, you know, if in the exam, what will happen? So suppose the 5 steps are there, and this sort of sum will come. Maybe I will assign 1 point to this step, 1 point to this step, 2 point to this step, 1 point to this step, and 1 point to this step. So altogether 5 marks. So this sort of sum will come in the final exam for the 5 marks, and individual marks will be allocated for the individual steps. So keep that in mind. It will be clearly mentioned. If they are asking just for the critical value, then just give this value, get the mark. If they are asking separately for the requirement, or maybe the critical value, or the Z states, or the margin of error, separately if they are asking, give the separate answer. Because your end-term exam paper has been already set, so I have complete picture in the mind. It's better to give you the, show you the what will be the form or the pattern of your exam. So altogether, suppose it's a 5 marks question, it will be a kind of separated one. 2 marks, 2 marks, 2 marks. So each and every step is important to understand. It's not only the judge's margin of error or the interval. Even writing these steps is very, very important.
Sorry.
Hope this one is clear, and let's move. Yes, please ask.
5, I can't see after the arrow. So 46 minus 0.31. Isn't it
Okay.
part 5? So like in red.
Yes, it is 0.031. It is this value. Let me see. P value is 0.031. Is that clear? Just multiply 1.96 with this value. I'm not sure what you are getting, but you will get 0.031. Did you get this one?
Yeah.
Okay. Now it is all right.
I can't see it.
You can't see this one. This is margin of error.
I can't see the arrow for part 5. Like 0.429.
Oh, this one. This is the range 429 to 491. Is it red color is not visible to you?
0.31 and plus 0.31. 0.031.
This one you can't see. Which step? Could you tell me which steps is not clear for you?
So it's 46 plus and minus 0.031.
Okay, this step. Okay.
And then I just can't see the answer behind that. I think it's probably my laptop quality.
Wait. You want to? Okay, this range you don't want. You are not able to see. This range is. Let me write. Maybe I want to use the red one. 429 to 0.491. Now it is visible, right?
Yeah.
Did you get that answer? Or you're just writing the answer? Did you get that 0.031?
Yeah, I got that one, but I don't get the one that you just wrote.
Why? What is the, oh, it's 46. No, it's 0.46. 0.46 is p hat.
Okay, yeah, I get it.
P hat minus e, okay, this one.
Yeah, I didn't see the point. My bad.
Okay. So what is the step number 4 is p hat minus e and p hat plus e. So p hat is 0.46 minus 0.031 margin of error and then 0.46 plus 0.031. So if you do this sum, you will get 0.429, and if you do this sum, you will get 0.491, and that is the confidence interval. Is that clear, Rhoda?
Yeah. No, it's Reina.
Clear, right?
Yeah.
Okay.
I just didn't see the point.
Okay. Still you are not able to see, or should I move to the next question?
It's okay.
Wait. One more thing I can do, just quick. Okay. Can you see here on the board? Is that clear now? See on the screen.
Yes.
Yeah, it's clear.
The same thing we got, right? So you have the answer over here.
Is that one on Moodle?
I will upload it if you want.
Okay. Okay, no worries.
No worries. I will upload for today's one on the Moodle.
Yeah, thank you.
So go through the exercise second then. Let me share this one, exercise second. Okay, exercise number second now. Go through the exercise number second. Okay. A random sample of 200 students from a university were asked if they regularly eat breakfast. It's a random sample. 84 students responded that they eat breakfast regularly. So 84 is our interest of area, right? Out of 200. Calculate the 95% confidence interval for the population proportion of the student who ate breakfast regularly. What we can do is, what is the value of n here? They are saying it's a 200. Question is clear, I'm sure. So just work on individually. You can work on this exercise. Find out what information is given and follow all 5 steps we just now discussed. What is n value? N value is 200. Again, this is the case of proportion, because 95% interval for the population proportion, if it is clearly mentioned, you don't have to worry. It's so simple to identify. This is the case of proportion, not the case of mean. In that case, they could have given you the standard deviation of population. Okay, hang on here, or maybe some wordings like the population mean or the sample mean, something like that. So this case is again a sample proportion, case of sample proportion. What is p hat value? So out of 200 students, the sample of interest for us is, sample size of interest is for us is 84. So p hat value will be 84 divided by 200. So this is p hat will be 0.42. Calculate the 95% confidence interval. So just same like the last one, 95% confidence interval. What will be the alpha value? Same like 0.05. Alpha by 2 will be 0.025. And then seeing the alpha by 2 or alpha value, you need to, it helps us in calculating the critical value. Okay, so first step, you know that this sum is on the proportion, sample proportion, confidence interval they are asking. So keep in mind 5 steps. Step 1 is NP hat and 1 minus P hat. So what is NP hat? NP hat is the same, 0.42 into 200, it will give you 84. 84 is greater than 5? Yes. And 1 minus P hat, 200 into 0.58, that will give you how much? It will be around 116. Greater than 5? Yes. So 116 and 84, both are greater than 5. Requirement is fulfilled. I can proceed with this sum because I'm using this one. I'm applying the LTV, that if you could remember the critical theorem. So using that one, we are assuming that this curve will be will be approximately normally distributed. Second one is calculate the CV value, critical value at Z alpha by 2. So again with the table, you will get the Z alpha by 2, same like the previous one, 1.96. The step number 3. I know this is like more important. If you do mistake here, your answers and interpretation, everything will be 0. So be more careful. So Z alpha by 2 multiplication by P hat 1 minus P hat divided by N square root. P hat value is given 0.42. So 0.42 into 1 minus P hat will be 0.58 divided by N value is given 200 and square root. Solve these two. Z value is given 1.96. What E value you will get? Just solve this one individually. Don't be in rush.
The E value
Yes.
0.069.
0.069 or 84 exactly. Very good. Others, you try to get the same number. Try to find out the E value. It should be around 0.069. What Betty just she has said. So those who got this one, try to move for the next stage number 4. Find out the values, interval CI values. CI values is P hat minus E, comma P hat plus E. So what is the P hat? P hat is 0.04. So 0.42 minus 0.069. So okay, 2 digit. 0.42 plus 0.069. sometimes it's very important. Let me repeat this one. Somebody can do all these two sum together, like Z alpha by 1.96 into all these factors together. If you do, you may get one number, but if you round off here, if separately calculated the standard deviation value, and if you made a round off here, and then if you are multiplying with 1.96, somehow you will get a different answer. Are you getting my point? So don't try to do the round off here while calculating the standard deviation of this value. Don't try to make a round off here, because with this value you have to multiply with the 1.96, the critical value. So don't try to make a round off here. Is that clear? It's very, very important. Why sometimes your answer is like deviating with 1% or 1.5% or 2%? The reason is you already did a kind of one round off here. Don't round off, because the final answer has to be round off. If margin of error is the final answer you are supposed to get, don't try to round off here, because with this, if you round off here and then if you multiply with 1.96, the chances are there that 1% there will be a difference between my answer and your answer. This is very important. Is that make sense?
Yeah.
Yes, this is very important. Don't try to make a round off here itself.
Yeah, so without rounding off, it's 0.0684.
Exactly. It's okay, fine. This is the final one. Over here, you can do the kind of round off. Or even you can do more fine, like fine, you can refine here itself, doing the round off.
All right.
Anyway, if in one, like a margin of error, if you're rounding it here, that is fine, not a problem. It won't lead you to the wrong answer. It will be very, very minimal differences. But don't try to round off here, because sometime in the last exam it happened with some of you. My answer and your answers were matching with deviating from 1% or 0.84 or 0.46. The reason is you already did the kind of round off here and then you are multiplying with here. So don't do that. Whatever value you are getting in your calculator, just use that value and then multiply with the 1.96, and then together, then you make a round off here. So what is the answer here you will get? It will come here 0.3516, right?
Yes.
0.3516.
And then 0.4884.
Exactly, 0.4884. Very good. I have noticed that some of you are very active here, more interacting over here, like interactive over here, performing really good over here on the screen when we are discussing and talking, and I'm really happy. But when I see sometimes your performance in the exam, I don't know why this happens to some of you. You are not able to perform good, or at least as per my expectation in the exam or in the quiz. So just I think what is lacking here is like you should devote more time in terms of practicing. If you are not having the new questions, you can do the same questions. You can repeat as much just for the practicing. Each and every time you will attempt the same question, maybe your understanding will improve. So just maths is all about statistics is all about the practices. So do it. Okay, so you got the interval.
Sometimes we just don't know what we're doing wrong, I think.
So let me know. See, whenever you see the question, try to see clearly. Take some time, give some time to understand what they are asking for. Because in the statistics, we have seen various formula to calculate Z value, Z alpha by 2, T stat or T alpha. There are various formulas for standard deviation, and so what is very important, the application of the right formula. Like in this case, we have a formula of Z alpha by 2 into P hat 1 minus P hat divided by N. But whereas in the sample distribution of the proportion, we have seen the formula Z into P 1 minus P hat divided by N whole square root. So it looks like similar, all the formulas, but which formula has to be more appropriate. For that, you need to understand, you need to read the line in the question itself. With the practice, ultimately, I have only one word to say: practice, practice, and practice. With the practice, only your understanding will improve. Those, I'm sure, those who are nowadays getting centum, I mean, out of 40, they are getting 40. Out of 20, they are getting 20. I'm sure they are working very hard, or they are giving their best time. They are giving quality time. I mean to say, people are, even sometimes you think that you are giving time, but are you giving a quality time where you're sitting and making a sum without any noise, background noise, or without any hindrance? Or sometimes you need to think about how to improve yourself by giving quality time to some of the subjects where you think you wanted to have more. So you need to think about and just practice. So since you got the, I know your intention is not bad. Always you guys are trying to improve. Even my intention is not. I wanted to have a kind of whatever knowledge I have, I wanted to transmit you. But depending on why somebody is doing better than others, maybe my perception says that they are giving quality time to understand, or but maybe the other regions, other factors are affecting you. So not everything is in my control and not in your control, but try to do your best. That is only is possible. So this interval we got. Then finally, what kind of assumption you have to, how to conclude this one? This time you have to write here, we are 95% confident that interval from 0.352 to 0.488, right, 0.488 does contain the population proportion P, otherwise population proportion of the student who eat breakfast regularly. It depends, right? Either you can, two different ways. Either you can stop here by saying that does contain the population proportion P, full stop. That will be fine. Otherwise, if you have more profound understanding, just write down does contain the population proportion of the students who eat breakfast regularly. Full stop. Both are correct. Just a quick recap on the screen if you are struggling. Yes, you see here on your screen, you can see the same finding is there. Is this sum is clear? Can we move to the exercise number 3 now? I'm erasing this one. What about the okay? Next will be exercise number 3. Let me show you the exercise number 3. Stop here. Okay. Oh, this one is pretty easy. Find the values T alpha by 2 in each of the following cases for the T distribution with degree of freedom 15. Okay, this one is like, do you guys have having a T distribution table with you? Do you have T distribution table? Otherwise, download it.
Yes.
Let me open the T distribution table for you, those who are struggling.
So for number 3 is the DF. We don't need the -1 from that anymore.
for the sum 3. Could you please repeat?
For the exercise number 3, so the degree of freedom, since it's given here, it's 15, right? Do we still have to minus 1 or no more?
No, it's already given.
No
So
more. Okay.
yes.
All
If
right.
sample size is given for this sum, the sample size will be 16. So straight away it is given degree of freedom 15. If it is not given,
Okay.
if they say that with the sample size 16, then you have to consider
Yeah.
the degree of freedom as
Minus 1.
15.
Okay, got it.
Useful in
Thank you.
terms of, very good question. Thank you. So let me open this one for you, the jet table, and then we will do this sum together. Idea is to just like have a kind of practice once again on the jet table. So more windows. Where is that jet table? Can't see the jet table. Why JetSco table is not here? Let me close some of the windows then. Let's see. Okay, this one is the JetSco table. Sorry, T distribution table. So we need to find out those T alpha by 2 value from this table. So what are they asking for? They are asking for 3 different ones. So they are asking for, so let me erase this one. So I think this one is done. We'll do the same confidence interval again for the mean. But before that, we have something interesting. So they are asking to find out T alpha by 2. T alpha by 2 value, T stats value at the degree of freedom 15 for the confidence interval is. So the first case 1 is confidence interval 99%. So for the 99% confidence interval, what is the alpha value? Alpha will be 1 minus, you know the tree, like 3 steps I say, 99 by 100. This is the proper step to get the alpha value. So you will get the alpha value as a 0.01. Then next step is to get alpha by 2. That is 0. I need to write 0. You guys are understanding that. So it will be 0.005. At the degree of freedom, DF, it is given 15. Sometimes it will be given the size, sample size. So in this case, what is the sample size? 16. So whenever the sample size is n, the degree of freedom is n minus 1. So 16 minus 1, that is 15. That's what it is here. So now, you need to find out the value using the jet table. So try to see on the vertical table. So now let me show you the vertical table here. I don't know what is happening. What is the jet table? I can't. Okay, anyway, you have the jet table. Can you? It's better if I can show you because some of you are. Yeah, okay, jet table. I got it. Sorry. Okay, so on the vertical, you see the DF, the right, the left extreme column. It's a degree of freedom DF. So remember, it's not n sample size. It's always DF. So whenever you have given n value, so DF will be n minus 1. So in this case, straight away they have given the DF 15. So go through the 15 and then at the point alpha by 2, 0.005 and find out the value. So let me take you through the annotation, which value you will get. So with the 15, So 0.05, point of 0.005. So it will go here.
2.947.
Okay, so 0.005 over here.
2.947.
Exactly. So what T stats value you will get on the screen you have seen. So T stats value will be for 99% confidence. So you have to write here T alpha by 2 like this. T alpha by 2 will be
2.947.
Exactly 2.947. 2.947. Those who has done, do the same thing for the CI 90%. For 90%, alpha value will be 0.10. Alpha by 2 value will be 0.05. Right? Yes. And then T alpha by 2. T alpha by 2 at the same degree of freedom. So let me see at the same degree of freedom. 0.05. In the second case, over here is the 0.05. So just drag it here and see what value you are getting. Yes, 1.758. So T alpha by 2 will be 1.758. For the third case, CI 95%. Right? So alpha value is 0.05. Is it a 90? Okay. Yeah. So alpha by 2 will be 0.025. So T alpha by 2 will be in the third case the same degree of freedom.
Isn't it one? Sorry. Isn't it 1.753?
Yes, I think I am because I'm not. Yeah, the second one is 1.753. Yeah. Actually, I did some drawing, so I was not able to see. So 3 looks as an 8. Just add one more 3 in the opposite side, it will be 8. So fine, thank you. So it's 1.753.
Yeah,
Find out
that's
the
the one.
CI value at the 95%. So alpha by 2 is 0.025. I think this is the third case. 0.025.
2.131.
Exactly. And then you just drag at the down 2.131. So the value is
3.286.
no, it's a 2.131.
Oh,
You see, I also did on the screen. Are you not?
yeah, 2.131. Sorry.
Yes. Every one of you, please try to get all these values. Very important. An exam, the T table will be provided. Even the Z score table will be provided. T stats will be provided. So everything will be provided. So you just have to know like how to use that table.
The last one, the third one, the 95%
It's meant to
confidence
be.
interval, is it not 3.286 like you said?
Yeah. I was checking again and I was like,
Yeah. Are we not looking at the right one?
Is it something incorrect?
Yeah, the third one.
Let me see that. Okay, okay. What is wrong here? I think you have pointed out here. No, yes, it is for 95%, right? No, this is correct. Which one is yours?
it's 0.025, not 0.25.
No, it's 0. You just make it half, right? If you make it 0.25, it is 50%. How can it is?
You did for 0.25, not 0.025.
What is the correct one then?
3.1 something. I don't have the jet table again.
Do it now and find out. This is the right answer.
Let me get the jet table.
Yeah, please take your own time. Don't let you be rush. But only be careful. You need to be careful in making it half. sometimes if you do the mistake over here, instead of writing 0.025, and if you jump to 0.0, like 0.25 or something, maybe you will do the mistake. Did I perform any mistake?
I think you did something wrong.
Let me see one
Because
second.
I think you put 15 and then like 0.25.
Okay, let me draw once again. Okay, let me check. I do mistake with you. It's fine.
Wait. I think you're right. I'm sorry.
Let me see once again.
I
Yeah,
think
but
you're right.
it's 15 and
2.131.
15 and
Sorry.
Yep.
Yeah, that's my mistake.
Alpha by 2 is 0.025. This value, right?
Yeah, that's right. Sorry. That was my
Yes,
mistake.
2.131.
Yeah, that's right.
What about other one more student? One more. Somebody was saying that he also got the another value.
I was looking at the wrong
Yeah,
one. I was looking at 0.0025 instead of
05, yeah.
0.025.
Fine, but what about the other guy? He also got the
Yeah,
right.
I'm the one. Yeah, I got right now, yeah.
Okay, 2.131. Very good.
Yeah.
Very good. Thank you. So let's go and to the exercise number 4. It is in front of you now. Exercise number 4. Let me ask you one survey question because sometimes it gives me a kind of confusion. I'm doing right or I'm doing wrong. So I need to, how many students? 41 is there. So let's do a survey. Add a question. I'm doing one polling, the kind of survey. So my question is, I'm writing one survey question. Did you enjoy that? Whatever response you will give, your name will not appear to me, but multiple choice. So yes, and no. How can I ask the question? I have one polling question. So where is the option for that? Add. Okay. No. Oh, I can't. Anybody, do you know how to do the polling?
No, sorry.
Last time I did the polling and it was working. It is the title of the questions here. I'm just struggling with like how to run the poll. You guys are not able to see the question, right? Okay.
Yeah,
Okay.
I don't see
Okay.
anything.
Did you see that question? Oh, okay. Okay. Now it came. I got it now. Did you? Okay. This is the polling, the first question, and just click it because I'm not able to see who is saying yes or no. Did you see any question here?
Yeah.
Okay.
Yeah, we can see the question.
Still more like yes, more 13 more or 14 more. So total strength is 41. Just do it. Ten more to go. Do it fast. Based on this analysis, I can do some sort of, if you think that like around 48% they are saying is still like, I know those who are enjoying the challenging questions and all, I'm really appreciating you, but I should worry about those who also are not able to reach at least the kind of certain standards. So accordingly, I need to do a little bit tuning in my question. So that's why like this survey is very important. And I will let you know why I'm asking, because I got the mail regarding some of the questions. Students, they are struggling. So they are also suggesting me to a little bit be like more tuning of the questions and all of the kind of pattern to change. That's why I thought like it's important to go ahead with this one. What about the 7 or 8 more students? They are not here. If you are here and not sleeping, please vote it and make it 100%. Yes, 4 or 5 more to go. I don't know. It's okay. 40, including me, it's 41. So 40 is, yeah. 4 are absent. Okay. Remaining 4, please do it fast. Last 10 seconds. Should not waste time. Please do it if you wish to do. Otherwise, let me take the screenshot of this finding from the screen. Okay, start with another sum, and meanwhile I'm just saving it. Thank you so much who have participated in this survey. Thank you, and I'm closing now. So around 53 is enjoying, but the around 47 is like facing difficulties. So I need to take care of everyone. So no worries. Oh, you guys are not able to see the result, right? This is the result. Did you see that?
Yeah, I
Yeah, we
can
can
see
see
it.
it.
Okay, so the same thing, 30, yeah, it's a 91, 19 and 18. So three of them, three, yes, out of 40, 37 participants has. So
With this question, are you asking about all the questions in the midterm or specifically the multiple choice?
overall, I'm asking actually.
Or overall, then I'd like to change my answer.
Okay, but there is no option. We already spent 4 or 5 minutes on this one. Anyway, like I got a kind of idea, like what should be done. But anyway, thank you so much. Like I can understand. So no issues on that one. So let's go ahead with the next questions. That is probably based on the mean. Okay, so exercise number 4. Ah. So number 4 is the random sample size 18 from a normal population variable x results in x bar 18.4. Till now, I'm assuming that you are familiar with the different notation. If I'm using x, capital X, what it does mean? Is it a population? Or if it is an x bar, what it does mean? So if you could remember in the population, yeah, probability distribution of the mean, we quite often we use this notation x bar. X bar is for the sample mean. So x bar is your sample mean. So instead of writing sample mean in the question, they have just given you x bar. So this could be a possibility in your exam. So what is the x bar value? Sample mean is given. So let me turn you to the back here. So x bar is given you, x bar value is given 18.4, right? What about S, capital S square? What is that? Anyone? Let me see like who is giving the right answer for S square. Capital S square, what is that?
Variance.
Could you pardon once again?
Variance.
Very good, very good. S square is variance. It's not a standard deviation. Don't do the mistake. Standard S is your standard deviation. Is it the, again, next question, is capital S is a standard deviation? Is that for the population or is that for the mean?
It's for the mean.
Exactly. For the standard deviation, for the mean. For the population, standard deviation is sigma. Whereas for the sample, standard deviation is capital S. So, what is given now? You have given S square value, not the S value. Remember, if S square value is given, in order to calculate S value, you need to make it, you need to make a square root. You need to get the square root of that. So X bar value is 18.4 given, S square value is given 15.44. So what will be the standard deviation in this case? What is the S value then? Corresponding S value?
39.29.
Could you pardon once again?
39.29.
I think it's 3.92.
No. How can
It's
Yeah.
it's 1544 or it's 15.44.
15.44.
Sorry.
Yep.
Yeah, then it's 3.92.
Yes.
Yep.
Simple one. See, the 5144 is just around 16. So your answer is around 4, right? 16 square root is 4. Just be careful. Just be careful. So standard deviation, you got it. Okay, now go through that one, confidence interval. This one, okay. What they're asking for? Find the 99% confidence interval for the unknown mean mu. So 99%. So the confidence interval 99% confidence interval, CI. So what is the corresponding alpha value? 0.01, 1%. What is the corresponding alpha by 2? 0.005. I think this is correct. For the 90, they are asking for confidence interval 99%. So let's go through kind of quick recap for the. This is clearly the case of confidence interval estimate for the mean. So let's go through that one. Not in this one, I think. This could be the another one. In the week 9, we have covered this one during the first 2 hours. We covered the mean. So let's go through this one. Okay, so this case, exercise or sum number 5 is clearly a case of, is it 4 or 5? It's a 4. Exercise 4 is clearly a case of confidence interval estimation for mean. Again, for the mean, we have 2 cases, sigma known and sigma unknown. Which case is this? Sigma unknown. Sigma value is not given. Instead of sigma, that is the population standard deviation, what is given? The sample standard deviation, that is capital S. Just now we saw that. So clearly this is the case, second case. Confidence interval estimation for the mean when sigma value is unknown. This is clearly you have to establish this one, that which case it falls. So when you have sigma unknown, let's go through that. Yes, the case second. Confidence interval estimation for the mean sigma unknown. So instead of sigma, it is clearly written that we use capital S in the place of sigma. Everything will be same. The sample has to be n greater than 25. Or maybe the t distribution closely. Okay. Okay. So calculate the confidence interval using the 5 steps. So requirement 1, the critical value, margin of error, confidence interval. So all 5 steps are same, the way we did in the proportion, right? Same, all the 5 steps. So the first stage, go through in this sum. What is the first stage? N equal to, n has to be greater than 25, or the population has to be normally distributed. It is clearly mentioned in exercise 4 that the sample is taken from a normal population. So it's normal distribution, it is clearly mentioned. Although you have sample size is 18, yeah, that is not greater than 25, but it is an or situation. So if the population is normally distributed, satisfied. And the sample has been drawn as a random sample, yes, it is mentioned in the first one sentence itself. What is the second one? Step second is get the critical value, just like the previous one. Step number 3 is calculate the margin of error, capital E. So instead of P hat was the previous one, we have T alpha by 2 multiplied by capital S, standard deviation, divide by square root of n. Keep that one in mind once we will do that. Step 4 is the same. X, instead of P hat, we have X bar now. Sample mean. So X bar minus E to X bar plus E. And then interpretation. We are certain percent of confident that the interval this to this actually contains the value, true value of mu, not the P, because we are talking about the population mean over here. So population mean is denoted by mu. So all 5 steps are known. So just go and follow the 5 steps and let's try to do this sum together.
So, step 1 requirement is fulfilled. Yes, because it is mentioned here that the sample has been drawn from a normal population. So, normal population is normal distribution. So, that criteria is fulfilled. Second, find the critical value. So, how to get the critical value? At the 99% confidence interval, what is alpha value? We have calculated alpha by 2. So alpha is 0.01. Alpha by 2 is 0.005. So what we have to find out here? This is the case of student T distribution, right? Not the Z distribution. Did you notice that formula? I think I have not clearly repeated the same thing. You see how to calculate the E. It's a T alpha by 2. That means this is the case of T statistics, not the Z statistics. So, you know, just now we had some kind of exercise how to get the T value. So try to get the T alpha by 2 value at 99% of the confidence interval. Find out this value. For the degree of freedom, how much? Who will tell the degree of freedom in this case? N is given
X.
N is given 18. Right?
Minus
Random
1.
sample of size 18. So N value is given 18. What is degree of freedom? DF?
17.
Exactly. Find out the T starts value. Do it by your own. Find out. This step is important. Finding the T starts value.
Mr. Amit,
Yes.
I think the S1 must be 3.9.
3. Correct?
Yeah.
Exactly. I don't know, like how you get this number. Who said 3.44? Thank you so much. Because the S value will be 3.93 instead of 3.44. Who get this value 3.44?
I think the one she said a while ago was 3.9.
Okay, maybe I have.
Yeah.
Okay.
Maybe misheard. Yep.
No worries. So 3.93. Very good. So come here, like get this value, T alpha by 2. What do you need? Alpha value. Alpha is 0.005. Whereas the degree of freedom with an 18, degree of freedom is 17. Find out this value.
2.898.
Could you repeat?
898.
Others, you should get this value, 2.898. Let me know who is not able to find this value. Be honest. If you are not able to find this value, please ask me. I will show you step by step. Even I can show you how to get this number. Try to get it, and if you are not able to find this value, you need to practice more. That means. Others, did you get that? I think, let me take you to the graph. It's very easy. Using the application of T table is not so much rocket science. You see in front of you, so T alpha by 2. Did we calculate the alpha by 2? Yes. So let me take you through the drawings. How much is the degree of freedom? 17. So 17 is here. So I need to move in this direction, I think so. And I will stop at alpha by 2, 0.005.
So where it is? 0. I think this is the same value. 0 point alpha by 2. This is, remember, this is alpha by 2 on the top. Did you get the same value? 2.898? I'm sure you will get the same thing. Okay. So the next step is step number 3. You need to find out what? Margin of error. So capital E. For that you have a formula of T alpha by 2 capital S divided by square root of n. Is it the same, right? I think so. This is the same one. Find out this value. T alpha by 2, how much it is? T alpha by 2 is, we got T alpha by 2, 2.98898 into capital S. Capital S is 3.93. 3.93. Divide by root square of n. N value is 18. Remember, it's 18, not 17. Degree of freedom is 17, but n value is 18. Remember that. Get the correct value of this one. If you're doing this one separately, don't round off. Get the correct one, the all together, and then make a kind of round off at the end while having all the calculation. This into this divided by this. So do it and let me know how much is the margin of error.
It's 0.00683.
2.684.
All together, you are saying?
Yeah, altogether.
Yeah, 2.68.
That's what I got too.
You
Yep.
should get 2.684.
Yeah.
Yep.
What is Janet? What is
Maybe you
Don't
haven't
forget-
multiplied with, yeah, the
Yeah.
2.898. You have to multiply it with that. Maybe that's why.
Oh, you can talk in here. It's fine. I'm not yelling. So why are you even
You
doing
get
that?
it. You try to get it by your own. I will not move to the next steps. You try to get this number. This is very important. Where you stick it. This is the point you are not able to get the right answer. That's why the step number 4 and 5 is wrong. So everyone try to get this number. And if you are not getting this number, something is wrong. Get this number, please. I think
Yeah, it's 2.684.
yes, 2.684. Thanks for
Yeah.
confirming. But try to get others. Please try to get this number. I think the way you operate the calculator, maybe that there is an issue. Try to do this one as smartly as possible. This sort of calculation, because throughout the two hours of internal exam, you will be having lots of around 80 or 90. This time, around 80 or 90% will be calculation. So around 80%. So try to be like smart in doing the complex sort of multiplication, division all together in the single sum. And never try to do it separately and then round off and then multiply with 2 points. Don't try to do it. In this exam, the final exam, I have strictly mentioned that your answer will be in the round of 2 digit. Round of 2 digit. This is important. Not digit, 2 decimal point. Round off your answer with 2 decimal point. Please, everyone, please note this one. It will be clearly mentioned in your instruction and guidelines in the paper. The 10 minutes will be allowed for reading the instruction at the beginning, but keep that one in your mind. I have clearly mentioned that round off your answer to 2 decimal points. That means if something is coming like 95.754, if this is the right answer is coming, your answer will be, you need to provide me 90.5 into 75. And if it is 16.438, that means it will be 16.44. Just try to.
I'm asking for 2 decimal points. This is important. So you should provide only 2. Don't provide in the answer sheets, because end-term exam I have to take the printout and then I have to go each and every. It's like various sections and subsections. Like this question again will be, suppose this question will be a part of your exam. So it will be a 5 marks total. So 1 marks will be the first step, second 1 marks, or maybe the 2 marks. This one is 2 marks, something like that. And finally 1 marks. So it will be a clearly like different level of marking is there. So just try to have a 2 decimal points. Although we are doing here the 3 decimal points, but for the 2 decimal points, this key margin of error will be 2.68. So that is that. Otherwise, you just do the, if the final answer is confidence interval, over there you do the, to take the consideration of the 2 decimal point. So if the question is for the margin of error, then provide 2.68. And if it is a question for the confidence interval, in that case, in that one also, you provide with the 2 decimal point. This is very, very important. I will keep repeating you till the actual exam. Okay, so you got this answer. So move to the question of like step number 4. What will the value in this case? X bar minus E, X bar plus E. Let me know what range you will get. You must get
15.716.
15.716, correct? And the second one is 21.084. So if this is the question, the confidence interval, you have to write only answer. So with the 2 digit, you will write 15.1716 will go to the 2. More than 15, so 2. And 21.084, less than 5, so 2. For the final exam, you should provide this number. For the final exam, you should provide 2.68, not this one, not 3 digit, only 2 decimal points. So 0.68, 0.08, 0.72. And finally, the stage number 5. Stage number 5, what is that? We are, this is the case of 99%. So we are 99% confident that the interval from 15.7 to 21.08 does contain, important here, interval does contain, what is that? The population does contain a true population. This is the case of population sample mean. So with the finding of sample statistics, we are trying to generalize something about population mean. So does contain, this interval does contain a true population mean. You know how to denote that? Mu, full stop. So, is that clear? They were asking, right? Find a 99% of confidence interval for the unknown mean, unknown population mean mu. That's why we did this generalization. So with this interval, it does contain a true population mean, that is mu. So that is exercise number 4. How many are remaining? Okay, 2 more to go. Do the exercise number 5 fast. Exercise number 5. A random sample size of 41 from a normal distribution population X and result in X bar S square is given. Find the approximate 99% confidence interval for the. Looks like the same thing, kind of. But it's better to do it. The practice makes you perfect. So just do it quickly. Don't take much time because it's exactly the similar sort of question. So I'm just doing it. You also do in 5 minutes. So n equal to 41. So in that case, degree of freedom will be 40. X bar is given 75.82. S square value is given 16.16. Find out S value. Okay, let me write down, then I will increase. And the confidence interval is 99% confidence interval. So let me take you to the whiteboard now.
Sir,
Okay, please ask.
sir, I have a question,
Please ask.
but it's about the final exam.
Oh, please ask.
In the final exam, are we going to be doing questions on Excel worksheet?
No. We are not going to have an excess of. We are not going to sit in the lab to. So there will be no exam on the Excel. Excel's like sometimes we try to see like how the same similar stuff can be done in very quick manner in the Excel. But probably in the once you will go to the higher level of statistics, higher level of understanding of statistics, maybe the different courses, you will have a more Excel sort of exam. Like exam will be based on some portion of it will be based on the Excel, but not in this because we are doing everything, all the calculation on manually. And
Okay.
in the exam, sometimes in one of the questions, if I could remember, I have given you the Excel output. So you just have to understand how to analyze the Excel output. Are you getting my point? This is very important.
Yes.
We will not allow you to like do some Excel calculation. That calculation itself, the output I will provide to you, and you have to do some sort of interpretation. So you don't have to work on the Excel.
Okay, thank you.
So this sum, just try to do it fast, because this sum is exactly the same one which we did last time in the previous one, the exercise number 4. So just try to have. So all the data is here, 75. What is the value of S you will get? 16.16, you will get 4.02. So the first condition stated that it's a random sample, and it is also mentioned that population follows the normal distribution. It is mentioned in the question. So criteria is fulfilled. Second one is the critical value, CV value, critical value at 99% confidence interval. So the alpha value is 0.01. Alpha by 2 will be 0.005. Now, what do you think? This is the case of T distribution, right?
Yeah.
So the T alpha by 2 at 40 degree of freedom.
2.704.
2.704. Yes, others. Please, could you confirm? Very good. Others, please confirm this value using the jet.
Yeah, it's 2.704.
Very good, very good. See, with the practices, you are taking less time. Very good. Thank you. Proceed with the step number 3. Find out the E value. Alpha by 2, that is 2.704 into capital S, 4.02 divided by square root of n. N in this case is 41, not 40. To find out the E value.
1.69.
1.69. Why you left the 3 digit? Did you round up with this one?
It's like 1.697.
7 or 8 something, right? So don't see.
Yeah, you can go with 8.
Exactly. And if you are giving me the answer in 2 digit, then it should be 1.6. How much it will be then?
1.70.
Exactly. Don't do this mistakes. You should not do. Because unfortunately, this time we are sitting online, doing exam online, and I'm asking you to give only the answer. I'm not looking back to your like what steps you have taken. So please be careful in terms of even rounding off. So if you're giving 2-digit means look at the 3 digits, then do the rounding. Don't just pick up 1.69 because important points you are leaving here, 0.008, that gives you kind of big contribution. So you should be careful on that. So just stick here with this one. If the answer is, if they are asking for margin of error, then just give me in the 2-digit 1.70 instead of writing 1.698. And if the question is on the confidence interval, then find out that one first. Don't, for the confidence interval, it will be x bar. So x bar minus e to x bar plus e. If the answer, the question they are asking for x bar minus e, don't round up here now. Don't do that. Go here with the x bar. What is the x bar? 75.82 minus 1.698. I'm using 3-digit here because finally we'll do the 2-digit. Then 75.82 plus 1.698. What is the answer? Do this sum.
Wait, sir. How come you didn't use 1.7? Sorry.
How did you get this one? Could you ask?
74.12 and 77.52. But I used 1.7.
Not if, see, if the question they are asking, if suppose separate question is there, they're asking for this one as well as this one, right? Then for this one, you just give the answer 1.70. For this one, this part. If in the question they are asking not this part, they are asking for the confidence interval, then don't do it like round up here. Do the round up.
With 1.7, you are still getting two significant number, like two decimal place.
That is okay. That is okay. But I'm trying to make you a bit perfect. Like, try to understand what I'm saying is, if the question is 1 marks is there for this step, suppose in the exam, then you give me 1.70. But if suppose in the question there, I'm asking just for the confidence interval, 2 marks. So no need to have a round up here. Do the round up here. First, let me know how much it is coming.
74.122.
Okay, 122.
518.
518. So if suppose the question is give the confidence interval and that carries suppose 2 marks, do here the roundups. 74.12 to 77.5118 will be 52. Give this answer to me with the 2 decimal digit. Is that clear?
With 1.7, we get the answer what you wrote at last.
It's fine.
Like,
it's okay.
Same
Fine.
thing.
Okay.
Because
Fine.
it will be tough for us to remember all this stuff.
Okay, but try to. Okay, I got it. Even see, it will be a minus one. It won't turn. Maybe sometimes, or probably 90% probability is that it won't affect. I go with you. No problem.
And what he's trying to say is don't round up until the final questions when you already done all your calculations.
Okay,
and if passed, just round it up from there.
Very good.
Yeah.
Very good. Because if the question is CI, confidence interval, then don't round up anywhere in it. That is my case. But if the question is separately this one also and this one also, then do it here and check the same.
We'll do the roundup at the last question. That's the thing.
Which one?
Like if you are ending the question at number 3, then we will round up at number 3. Or and if you are
Exactly.
Yeah, got it.
And if there is no question on 3, then only the question is CI, confidence interval, find out. Then round up at the stage 4. That's what I was trying.
Yeah, got it.
Unfortunately, the reason is I'm not able to see your back calculation. I could have given you 100% marks because I've seen, if I could have seen your all the back, your rough draft version, draft work, or how you proceed. But unfortunately, I'm not in a position to see your calculation. That's why this is happening. Otherwise, there is no need to do this much of.
Yeah, got the point.
So this one is okay. And finally, the conclusion will be we are 99% confident that the interval from 74.12 to 77.52 does contain the true population mean, that is mu. Full stop, job is over. Quickly go through the next exercise, exercise number 4, 5, 6. This was like similar sort of question, so no need to spend much time. Yeah, next question. Is it the same on the population mean or something different? Let me open that one. The next question. We're running out of time. But it's okay. Exercise number 6. Okay, let's do this one. Find a 90% confidence interval for the mu for the sample given values is given. Okay. It's better to do this one with the Excel sheet, I think so. Yeah. From exercise number 8, 9, and 10 and onwards, this question, this sum we will do it when we will do the hypothesis testing. Remember here, you see the question, what they are asking for. 15, can the claim will be right or wrong? Hypothesis rejected or not rejected? So the question number 8 and all will do it in the maybe the next week. So how many questions are remaining here? So 6 and 7. So let's do it with the Excel sheet. Can you import these data in the Excel sheet? Let me open the Excel sheet. Anything on the desktop? Wait. Practice. Did you import the data on the Excel sheet?
Sir, it's better if you share the screen of the Excel sheet.
Yes,
And
I'm
so
trying
then
to
we can understand how to do it.
Actually, I'm trying to open it, but it's taking time. I'm trying to.
Okay.
Okay, I have opened the Excel sheet, but let me write the values on the Excel sheet.
Should we write all the values?
In the Excel, yes. Then only it will give you the values, right?
Yeah.
5103. Just type it vertically.
Okay.
Just type it vertically. 95, 103, 107, 98, 90, 10, 108, 90, 94, 105, 109. Now I will share with you this sheet. Okay, you could see that all the 10 numbers, how many numbers are there? Let's see that. 1, 2, and then taking these two, I drag. This and this. And then you see how many numbers are. Okay, so what is the sample size? It seems 12, right? Are you able to see the Excel sheet?
Yes.
Yes.
Okay, so see these two data sets. I mean the data
One is count and one is the actual data, which I borrowed from the practice set. So that you can do it here. Okay. What is next step? Just follow the steps given. So next step is descriptive statistics. Go through on the data you have on the right extreme, data analysis. Click that. On the right extreme on the top, you have data analysis. Just click that. You will get this window. One window will be pop up on the data analysis. By default, it is hanging at the descriptive statistics, and that's what we are looking for, right? Yes, descriptive statistics. Provide the range. And remember the questions. Question is at 90%, right? Okay. See the question, you need to find an approximate 90% confidence interval. So 90%. So keep that one in mind. Okay. In the descriptive statistics, now you have, okay. They're asking for input range. So click here, give the input range here. The column B5 in my laptop, it is B5 to B16. Then enter. Grouped by column, yes. Did we choose any level? No labeling. So no need to take this one. Output you wanted where? I wanted output in the same Excel sheet. So output range, click here, give any cell so that output will be displayed over here. Are you interested in summary statistics? Yes. Summary statistics will give you the mean, median, mode, range, p-values, everything. So you must click this one, summary statistics. Okay. Could you see in this question, it is mentioned that find an approximate 90% confidence level. By default, in your Excel sheet, it will be 95%. By default, confidence level of mean, 95%. You need to change that because in these questions, they are asking for 90%. So I changed 95 to 90% confidence level of mean. That's it.
Wait, sir, what do you put in output range? Sorry.
Output range. By default, they are asking for, they will take the new worksheet, right? Then they will open the new worksheet. But you want in the same worksheet, then click on the output range.
Yep.
Click on this table. Give anywhere. Click any of the empty set. Don't give anywhere in here, such as here or there. It will be too extreme. So in the open space, you just give anyone.
Okay.
And then just press OK.
Okay, got it. Thanks.
You will get the summary statistics like this. For the data which is given, the summary statistics. So even in the question, if I ask this sort of question, I will give it this output. So what is given here now? Mean value, standard deviation, standard error. So remember, the second one is a standard error. It's not a standard deviation. So be careful. Standard deviation jumps here, 7.2. You have given median, you have given mode, sample variance. Standard deviation is if just a square 7.2, it will give you the variance around 52. Kurtosis and skewness, no need to worry about now. It checks the normality of the data. Probably as a researcher, you will understand all this. Okay. Range is 20. You know the range, which range they are saying? Starting the lower one and you could see here, the maximum 110 and the minimum is 90. Just subtract, you will get the range. It's not an interquartile range. It's not interquartile range. It's a normal range of the data, low to max. So now you got it. What is the P confidence level 90%? It's this one is known as your margin of error. Let me write here. this value is your margin of error. So instead of calculating very soon, or like calculating using the, you know, if you do, you can do this one with the normal one. I mean to say, like, if you use like the t stars, can you get the like margin of error E using the formula t alpha by 2? You will get the margin of error value as a 3.73. Are you getting what I'm trying to speak? This is a sample, right? So what values are given? N equal to how much? N equal to 12. So what will be the degree of freedom? DOF will be 11. Okay, what is the alpha value? What is the alpha value? 90%, right? So 0.10. So alpha by 2, exactly
0.01.
No, that is alpha value. Okay, alpha by 2 point.
Alpha by 2 is 0.05.
Exactly 0.05. Very good. So if you got what is missing? What is the standard deviation as capital S value? Tell me.
It's 7.2.
Exactly. Now you started reading, understanding. Very good. Okay, very good. What else? I think, can you get the T alpha by 2?
Yeah.
Yeah, get it? T alpha by 2? Let's see like how long you take doing this calculation. Get the alpha by 2.
0.8.
At 99.
1.796.
Tell me.
It's 1.796.
1.796. Okay. And with the T value, can you get the E value using the formula which is on the board?
Yeah.
Just try to get it, and let's see like margin of error is 3.73 is coming or not. We are cross checking it.
Wait.
Others, please do it if you are understanding, and let me know if you are not understanding anything.
Sir, sorry, where did you get 7.2?
7.2 is given a standard deviation in the table, column 1, standard deviation.
Oh, okay. Yep. Sorry. I see. Sorry.
Because this is a sample, right?
3.73.
Okay, so you are getting the same thing. Very good. You see that these two values are the same. 3.73 and this.
Oh.
Is